Okay, so here's the first sample problem. It says that an object is 10 centimeters in front of a plane mirror. You are behind the object and 26 centimeters from the mirror. What is the distance from your eyes to the apparent image? All right, so let's sketch the system. I have a plane mirror here. The object, let's just draw it as a little arrow. The object is 10 centimeters from the mirror. Right, and you are behind the object over here, right? You're observing, here's your eyes, right? You're observing the system and you are 26 centimeters from the mirror. Okay, now for a plane mirror, we know that the image distance is equal to the negative of the object distance. So that image forms on the opposite side of the mirror, and its absolute value is the same as the object distance, but it's negative. So here's our image over here. Let's draw that like in green. Okay, here's our image of the arrow. All right, so how far are you from the image? Well, you're 26 centimeters from the mirror, and the image is 10 centimeters behind the mirror. So the answer is 36 centimeters from the image. That was pretty straightforward. Okay, let's go on to the next one. Okay, so the next problem states that an object is 21 centimeters from a concave mirror with a radius of curvature of 30 centimeters. Calculate the focal length, the image distance, and the magnification. It also asks to sketch the system. I didn't go through ray tracing, but if you check it out in your book, you can see how to do ray tracing. I'm not going to go into it right now. It is something that you should know, but check that out on your own. All right, so the first thing we want to do is sketch the system, at least, the mirror part. Here's our object, here's our object, an arrow, and it's a concave mirror. Remember, a concave mirror curves towards the object. So our object distance P is 21 centimeters, but the radius of curvature of the mirror is 30 centimeters. Okay, so the first thing we have to do is say, well, the focal length, remember the focal length for a concave or convex mirror is just R over 2. So that's pretty simple. The focal length would be 30 centimeters divided by 2. So the focal length is 15 centimeters. It's a positive value, positive 15 centimeters. There's our focal length. Pretty straightforward. Okay, the next thing it says is to calculate the image distance. Well, we know that 1 over P plus 1 over I is equal to 1 over F. So let's plug those values in. I have 1 over 21 plus 1 over I is equal to 1 over 15. This is all in centimeters. When I plug those numbers in, I get an image distance of 52.2 centimeters. Positive, a positive value. Remember, we should expect to get a positive image distance since our object, our object distance is greater than the focal length. From that table that we talked about in the lesson, when the object is outside of the focal length, a concave mirror will form a real image. A real image is associated with a positive image distance. This image is real. That means it forms on the same side as the mirror, right? Or as the same side as the object, pardon me. So we would write this object, if we were to plot the object, it's all the way over here, 52 centimeters over here on the same side as the object. Now, what's its magnification? Well, remember, magnification is negative I over P. So we would write that as a negative 52.2 centimeters over 21 centimeters, and we get a magnification of negative 2.5. So actually, I drew this incorrectly, right? The negative magnification means that the image is inverted. And its value is 2.5, so it's 2.5 times the size, we'll draw it like that, of the object. So if the object is 1 meter in height, then the image will be 2.5 meters in height, and it will be inverted. Okay, that does it for the sample problems. Let me know if you have any questions. Have a great day.